Okay, Calculus and Vectors class, welcome to Unit 6. In this unit, we're going to focus on some other types of functions that we haven't really dealt with yet, namely trigonometric or sinusoidal functions and exponential functions. In this lesson, we're going to start with some trigonometric or sinusoidal functions, and we're going to see how we can use calculus to help us figure out more information about these types of curves. So before we do that, let's just take a look at some sinusoidal functions, some trigonometric functions, and we're just going to see what we can do with these to start. And you should notice with sine of x that we have a couple spots where the tangent is equal to 0, just like with any other function. With a polynomial function, we know that the derivative is going to be 0 at that point. So I'm going to start sketching our derivative using red here. So our derivative is going to be equal to 0 at that point, at this point here, at this point here, at this point here, all the way along, because those are all the spots where we have a maximum or a minimum. And now, next step, now we can start trying to figure out where it's increasing and decreasing. So let's see, for the first little bit, this is going to be increasing, then we're going to be decreasing, then increasing, and dividing around those spots there, decreasing, and increasing. So now that we have that, let's see if we can start kind of making a rough sketch of what it looks like. So for the first part, that means that the derivative is going to be positive, then negative, then positive, then negative, then positive. So as it turns out, when we do this, it's all above this point here, and then we get all negative, and we come back up again, and then we get positive, then negative, then positive. So now that we've filled all that in, I'm going to clean this up a bit. You'll notice that that looks very similar, and that actually is another function that we know. And in fact, in this case, it kind of looks like cosine of x. So as it turns out, the derivative of sine of x is dy by dx equals cosine of x. We can do the same thing for the cosine of x function. Let's try that. So let's start by marking all the spots where we have a maximum or minimum. We said derivative of 0, 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 all the way across. And then let's see, we start with some decrease, so that's going to start by being negative. And then we start increasing, so it's going to be a positive for our derivative, a negative, then positive. And actually, as it turns out, when we look at that one, the derivative for cos x turns out to be dy by dx equals negative sine of x. So we've just taken our sine function, we've just rotated it about the x-axis. So it becomes y equals negative sine x. We just reflected it about the x-axis. So now that we know that, now we can use that to help us figure out some important pieces of information. So let's try some problems here. Before we do that, let's just talk really quickly. I won't go through everything in this spot here, but this is basically just saying that all the other rules that we dealt with apply. The constant multiple rule, the addition and subtraction rules apply the exact same way. The only difference here now is that we're going to use some trig functions. So let's jump in and try it. So it's saying find the derivatives for the following functions. So first one is 7 sine x. So our derivative, just like if we had 7x squared, we would leave the 7 alone and we would differentiate x squared and multiply them together. So the same thing happens here. So it just becomes 7 times d by dx sine of x, or it becomes 7. We said the derivative was cosine of x, so it becomes 7 cosine of x. For the next one, we're going to do the same thing. And it works the exact same way. We're going to take negative 4, constant multiple stays the same, and we differentiate the other parts. In this case, we said for dy by dx that cos x, the derivative is negative sine of x. So the negatives multiplied together becomes positive 4 times sine of x. For sine x plus cos x, that's just the addition rule that we already know and love. So dy by dx, we're just going to differentiate each term individually. And let's see, sine x becomes cosine of x. And then cosine of x becomes negative sine of x. Or that just becomes cos of x minus sine of x. And lastly, one more. Now we're just going to combine that constant multiple rule with some subtraction. So exact same idea. We're going to differentiate each term individually, but this time we have a constant multiple in front of each one. So this becomes 3 times negative sine of x. And then we have minus 5 times cos of x. Let's just simplify that really quick. That's going to be negative 3 sine of x minus 5 cosine of x. So that's pretty much it for differentiation. Now that we have that, let's try some other types of problems that we've seen with other functions, but let's see if we can apply them to trigonometric functions now. So the first one, let's find the slope of a tangent. We've seen this type of problem before. We're just trying to find some sort of y equals mx plus b. And we know that to find, we are given x, that's equal to pi over 4 in this case. To find y, we're just going to plug it into the original function. So this one here, and that's going to be 3 sine of pi over 4. And that's just going to be, let's see, that's pi over, that's 45 degrees. So if you like to work in degrees, that'll be sine of 45. Either way, that's going to be 3 over root 2. And lastly, for m, we're going to take the d by dx, or we're going to take f prime of x at negative pi over 4. So to find that, we have to find the derivative. So that's going to be, in this case, it's 3 cos of x, or 3 cosine of pi over 4. And that's going to be 3 times 1 over root 2, or 3 over root 2. So now we have x, y, we have m. Now we just need to solve for b. So let's plug all that information in. Y is 3 over root 2. M is 3 over root 2. X is pi over 4 plus b. So let's simplify that a bit. 3 over root 2 is going to be equal to 3 pi over 4 root 2 plus b. We can move that over, and it becomes 3 over root 2. By the way, that looks like a negative, so let me just fix that really quick. Minus 3 pi over 4 root 2. That's going to be equal to b. Or just to help us out, let's get them over the same denominator to help us out. So we're going to take the first fraction and multiply it by 4 up top and on the bottom, so that way they're both over 4 root 2. So that's going to become 12 minus 3 pi all over 4 root 2. That's equal to b. So in this case, the tangent line, we have our m, we have our b. So y equals m is 3 pi over 2. So 3 over root 2 x plus 12 minus 3 pi over 4 root 2. So a little long and convoluted, but as you can see, the same rules still apply. Just make sure that you're being really careful about all of the arithmetic in here because it can get a little bit tricky. But otherwise, yeah, the rules still apply the exact same way. Let's try another one. This one says, find the equation of the tangent line to the graph of f of x equals -2 sine x at the point where x equals pi over 6. So same basic idea. So we need to find y equals mx plus b. So we need to find, let's see, x is going to be equal to pi over 6. Y is going to be f of x over 6, or -2 times sine of pi over 6. And let's see, sine of pi over 6 is sine of 30 degrees, so that's going to be -2 times a half, or -1. Yeah, that one worked out a little bit nicer than the last one, so that's kind of nice. So then we have m, which is just going to be f prime of pi over 6. So let's say the derivative of -2 sine x is going to be -2 times cos of x, or in this case, cosine of pi over 6. So just remember that f prime of x here is going to be equal to -2 times cos of x. So that's going to be, let's see, -2, let's see, cosine of 30 degrees is times √3 over 2, or our slope is going to be -√3. So now we have x, y, m. We can plug those in and we can solve. So that's going to be -1 is equal to -√3 times, let's see, pi over 6 plus b. Let's simplify that. -1 equals -√3 pi over 6 plus b. So let's move that fraction over. It becomes plus √3 pi over 6 plus b. Or we could rewrite this as that -1 is -6 over 6, and that would be -6 plus √3 pi over 6 equals b. Or if you want to make it a little simpler, we can just rearrange that just because we like to have the positive out front. √3 pi minus 6 over 6. So now we have m, we have b, so we can write the tangent line, which is y equals m was -√3x, and then we have plus √3 pi minus 6 over 6. Okay, let's do one more tangent problem just to make sure we've really got it. So, determine the equation of the tangent line to the graph of f of x equals 1.2 cos of x at the point where x equals pi over 3. Let's start by taking the derivative. Doesn't really matter. We did it in a little later on in the other problems, but we can do it whenever it makes the most sense. So that's going to be 1.2 times negative sine of x, or -1.2 sine of x. So now that we have that, let's start trying to find all the rest of our information. So x, it says that x is equal to pi over 3. So that's going to be, I think, let's see, that's going to be 60 degrees if I'm not mistaken. And then we have y is equal to f of pi over 3, which is equal to 1.2 times the cosine of pi over 3. And in this case, cosine of 60 is a half. So that's going to be half or 0.6. Next, we're going to find our slope. That's going to be f prime of pi over 3. And we found the derivative up top. That's going to be negative 1.2 times sine of pi over 3. Let's see, sine of pi over 3. What was sine of pi over 3? That was root 3 over 2. So that's going to be negative 1.2 times root 3 over 2. And then we can just divide that negative 1.2 by 2. And it becomes negative 0.6 root 3. So now we have x, y, m. We can solve for b. So let's do that. So y was 0.6. M was negative 0.6 root 3. And then x was times pi over 3 plus b. So let's move that bit over. It becomes 0.6 minus 0.6 root 3 pi over 3. But let's make it look a little nicer. Let's try and turn that into a fraction. So let's see that. If we wrote 0.6 as a fraction over 3, that would be 1.8 over 3. We're just multiplying 6 by 3, 0.6 by 3 and then dividing by 3. Minus 0.6 times 3, root 3 times pi over 3. And we're just going to combine that all together. It becomes 1.8 minus 0.6 root 3 pi all over 3 equals b. So now we have m, we have b. So the tangent line is going to be y equals m was negative 0.6 root 3 x plus 1.8 minus 0.6 root 3 pi over 3. So the math on this looks a little more complicated. There's a lot more pi's and square roots and things to juggle. So the arithmetic can be a little bit tricky. So it's important they do the practice. But I hope that you guys notice that the principles are exactly the same. The other differentiation rules apply the same way that we find the equation of a tangent line. The process is still the same. It's just the way they would differentiate and the math looks a little bit different. But the underlying principles are still the same. Just make sure that you try, do some practice, get a handle on working with square roots and pi's and differentiation all in the same package. We'll do the second half of this lesson in a separate video. So in the meantime, stay safe and wash your hands.